is lesson 6.3, number 7. And we're going to learn how to use your z-distribution chart. Now the standard normal distribution, remember that has z-scores. So sometimes I might use the expression, call it a z-distribution. When I say z-distribution, I am referring to the standard normal distribution. So we're on page, on the right page here, 302. Number 7, find the area under the standard normal distribution curve between 0 and 0.75. So what I want you to do on all these problems, and I'm going to put this one right below here, is draw a picture. It doesn't have to be fancy, doesn't have to be big. Draw a horizontal axis. Draw a little standard normal curve here. Z equals 0 is going to be in the middle. Z equal 0.75, would that be to the right of 0 or left? To the right. Positive numbers go to the right, negative to the left is just a normal number line. So 0.75 would be about right there. We're trying to find this area between 0 and 0.75. So to do that, you just look it up on your chart. And remember, these numbers down here represent z-scores. Z-scores tell us how many standard deviations something is from the mean. So, you go to your z-chart. In the left column, you look up the tenths digit, which is 0.7. So you go to 0.7 on your z-distribution table. There's also one of these in the back of the book, so if you leave this chart at home or something, or you lose it, you can always look in the back of your textbook. Then you go to so that's your tenths digit. Then you go to your hundredths digit, which is 0.05. Look up that up top. So then you come over from 0.7, you come down from 0.05, and whatever number you see there, that is the area under the z-distribution curve, under the standard normal curve. So what's that decimal come out to? 0.27 what? 34. Others agree with that? Okay, so that's that area right in there. 0.2734, and you're done. Now, look at the bottom of your standard normal distribution chart. It should say at the bottom, it should show you a picture that has some shading to the right of 0. The numbers you're going to get out here in the middle of this chart are always going to be the numbers to the right of that, to the right of 0. But keep this in mind, what if it asked you to find the area between negative 0.75 and 0? Say you get a question like that. So then you might say, okay, I'm going to look up negative 0.7 on my chart. But look at your chart down the left side. You see any negatives? Not a single negative on that chart, is there? So all you do is just look up positive 0.7 and positive 0.05, and you get 0.2734. But then, I don't have this drawn very accurately, but then you know that the chart's symmetric. So whatever area is to the right of 0, between 0 and 0.75, that same area will be over here. So the area between 0 and negative 7.5 would also be 0.2734. That's not asked for in this problem, but I'm just showing you that if they give you a negative, just look up the area that's to the right of 0, and the area to the left of 0 will be that exact same amount. You cannot have a negative area. Your area is always going to come out as a positive number between 0 and 1. By the way, what other numbers always come out between 0 and 1? What have we been studying that always comes out between 0 and 1? Probabilities, yeah. These areas actually represent probabilities. All right, let's go to a different one. Let's go to something like number, well, let's just go to number 9. Make sure you're understanding what I'm saying here. Number 9. Draw a picture. You have to draw a picture on every one. We're going from 0 to negative 2.07 on our z-axis. Trying to find this area. So you go to your chart. On the left side, what number do I look for? 2. All right, 2.0. Look at your ones digit and your tens digit. So 2.0. Then at the top, look at 0.07. That's coming from your hundredths digit. Go across. across, come down. That's going to give you the area to the right of 0. That's going to give you the area between 0 and 2.07. But because the graph is symmetric, we know that this area over here will be the same thing. So what's that come out to? Is it 0.4 something? 0.480. 8. Okay, so that area is 0.4808. Now later in the assignment, they might word the question differently. They might put this on the assignment. They might say, what's the probability that your z-score is going to be between negative 2.07 and 0? So instead of saying what's the area, they're going to say what's the probability, and you're just going to give the exact same answer. These areas represent probabilities, so this answer would still be 0.4808. So don't let that fool you when you get to the second half of the assignment. You're still doing the same thing, you're just asking it a little bit differently. Any questions on that? Let's go to number 11. They keep throwing a little bit of curveball at you each time here. Number 11, to the right of 0.23. So I'm going to draw in my curve again. Here's 0. 0.23 would be pretty close to that, to the right of it. So the area I'm trying to find is this area over here. Well, I just told you that this table doesn't give you that area. This table gives you the area just to the right of 0. So let's look up that area and see what we get. So go to your z-chart. 0.23, so go to 0.02, or I'm sorry, 0.2. Then go to 0.03 up top. Look across, look down. What number does that give you? 0.091. And then another 0?
Yeah.
Okay. So that's this area right in here. That's not what they're asking for. They want this area over here. So we already talked about this earlier. To the right of 0, what's the area, total area to the right of 0? 0.5. And this little area is 0.0910. What would you do with those two numbers to get this area? Subtract. Good. So I'm going to take 0.5000 minus 0.0910. That's going to give me 0.4090, I think. Is that right? So anytime you're trying to find a tail area, whether it be the right tail or the left tail, you're going to end up subtracting from 0.5. That's something to kind of take note of. All right, let's skip ahead to do one that's a little bit different. What if you got something like 15, where you had to go between z equal 0.79 and z equal 1.28? Draw my picture up here. There's 0 in the middle. Here's 0.79. Here's 1.28. These are all z-scores. I'm trying to find that little strip of area right there. Any ideas what you do? This is there's like a step-by-step procedure to do all of these, but there's no way you're going to want to memorize all that. I'm not going to let you use the book for the test, so you really have to just use logic. I know if I look up 1.28, this would be 1.2, this would be 0.08. I know if I look up that, it'll give me this entire area from 0 to 1.28. Let's do that first. Let's get that entire area. So, go over from 1.2 down from 0.08. What's that come up to? Say it again. 0.3997. So that's this total area from here to here. That total area in there, 0.3997. Okay. Now let's go to 0.7 and 0.09. So now I'm looking up the 0.79 right here. What's that come up to?
0.2852.
0.2856.
52.
52. So that's this area right in here, 0.2852. So what do you do with those two numbers? If I know this sliver, I know this total, what would I do with them to get this? Subtract them. Yep. You take your bigger area minus your smaller area. So I'm going to take 0.3997 minus 0.2852. And I think it comes out to 0.1145. Does that sound right? One thing to kind of check your work, you'll never have a negative area. When you're finding area, the area is always going to be positive. Okay? So that's that area right there, 0.1145. Any questions about that? All right, there's one other type that I could think of that I'm going to throw at you here. And I'm going to erase this example so I have room to do it. Let's skip ahead and do one more in the assignment, then I'm going to give you time to work. Number 35. 35 says, find the probability that z is between negative 2.46 and 1.74. So the capital P stands for probability. So the probabilities are represented by the areas under the curve again. So this isn't hard. All you do is you draw your picture again. You draw a picture on every problem. Put 0 in the middle. 1.74 would be somewhere over here to the right. It doesn't have to be perfect. Just put it over here to the right. Negative 2.46 would be further out here to the left. So negative 2.46. All we're going to do here is on the chart, look up this area to the right of 0. Look up this area to the left. This is asking me for the z value or the probability of being in between, so what will I do with these two areas? Just add them together. Yep. So go to your chart. Let's go to 1.7 first, and then up here to 0.04. So 0.04 comes from there. What's that come up to? Point something. 0.4591. Okay. Then go to 2.4. I know it's negative, but there's no negatives on the chart, so just go to positive 2.4, and then go to 0.06. Look that one up. What's that?
4931.
And I knew it was going to be bigger because negative 2.46 is further from 0 than 1.74 is. So I knew that the second answer would be bigger than 0.4591, because if you're further from 0, you're going to get a bigger area. So 0.4931. And then we're trying to get the total probability. So add those two together. If you add those together, let's just do that over here. 0.4931 plus 0.4591. 0.9522. Sound right? Okay. So we're just working on really using the chart, drawing the pictures. Tomorrow we'll start applying all this stuff to real life situations.